Nanotechnology is the science and technology of materials and appliances that are of the size of a billionth of a meter. In other words, nanotechnology is the creation and utilization of materials, devices, and systems through the control of matter on the nanometer length scale. Some time ago, we brought to you a program on NASENI Center for Excellence in Nanotechnology and Advanced Materials, where we showcased the amazing works of staff of that institute. We are revisiting the institute to enable us present many other aspects of their laboratory activities in nanotechnology application. The National Agency for Science and Engineering Infrastructure had indeed perfected its act in all areas of science, technology, innovation, and nanotechnology. And the NASENI Center for Advanced Materials Laboratories can boast of advanced lab technology equipment first of its kind in Africa. We thank you for joining us as we evaluate capacities of Nigerian scientists and engineers. But first, let me introduce the Executive Vice Chairman of NASENI, Professor Mohammed Haruna.
With the materials advancement, through the intervention of World Bank, NASENI won the competition for proposals to establish a center of excellence in advanced materials and nanotechnology, the best and the first of its kind in this region, with state-of-the-art equipment in Akure. This center of excellence has facilities for nano technology and advanced materials. There we are able to characterize nano indentation and then advanced technology and even production of products using the application of nanoscience and nanotechnology. The center has facilities that industries use to come. You see, if you have any materials, you discover any uh, precious materials or solid mineral, the place has the ability to characterize, to tell you this equipment you are seeing or this piece you are seeing is a nickel, it is sodium, it is this, and this is the composition. So it can characterize, it can indent, it can analyze and tell you the quantity, the volume of things that are there. Again, it do other processes that enhance, particularly when it comes to alloy. You want to know the percentage of each item in a materials. Industries, academia patronize uh, that center of excellence in nanotechnology and advanced materials. The center has its own center manager because it is one of the commercial outreach of NASENI, as well as research and development into new and emerging materials. And that is where we experiment if we develop any equipment to see the strength, the durability, the quality and performance of workpiece we need to do in the production of other machines and spare parts in our system.
Science, technology, and innovation hold the key to the progress and development of any nation. In Nigeria, the National Agency for Science and Engineering Infrastructure, NASENI, is the catalyst for a paradigm shift from the utilization of conventional manufacturing technologies to advanced manufacturing technologies. Through its development institutes across the nation, NASENI is involved in the areas of reverse engineering, nanotechnology, advanced class content, education tools, agricultural equipment, and pioneering projects in the manufacture of solar plant models, electrical and electronic products, multi-purpose machinery, and lots more. Join us on NASENI Milestones and learn more about nurturing an appropriate and dynamic science and engineering infrastructure base for achieving home-initiated and home-sustained industrialization for Nigeria. NASENI, creating enabling environment for local mass production of standard parts, goods and services required for Nigeria's technological achievement. We begin our tour of NASENI Nanotechnology and Advanced Materials Institute with a stopover at a laboratory housing the DPN 5000 nano lithography machine.
This equipment is called DPN 5000 nano lithography. So essentially this equipment is a nano lithography device, and the basic principle of operation is based on using atomic force microscopy tip to write the whatever we want to write. So we can write molecular material on a substrate, maybe on a polymer substrate or glass substrate. So we have, so in this way we open the equipment, and then this is the writing head, both scanning and writing head. And we also have the stage here. This is the mounting stage or the writing stage. So typically we have like an ink well. So where we are going to put the molecular ink. Here we have a 9 well. No, this is 12 well. This is 3 by 4. So we have 3 wells in 4 rows. That is 12 well ink well. And so here we place it on the stage. And so this is the material that we want to write on. So we want to write, be it a molecule or whatever. So we put it by the side, and then we mount it onto the stage. So this way we take this out. So and then this is the writing edge. You can see that we have this. So this is the pen. This is the writing pen. So it's a very small of order of nanometer in the tip that is on the head, and very fragile. So care must be taken care. We must take very good care when we are trying to scan and write on a surface. So we return it back, and then we lock the head, and then we place the stage there. And so after we have done this, so we close the door, we lock it, and then we come to the control station, which is this computer here. So basically, everything that needs to be done is operated through the computer. And so you start the software. After you start the software, so you set the parameters that you want to use in your writing, the thickness of what you want to write, and also you select the type of pen. So there are different kinds of pen. There is pen that is just one tip. You have pen that has like 10 tips. So starting from 1 to 10 tips. So we can select any of the pen depending on what we are trying to write. And this writing, like I said, is a nano lithography. You write at nano scale. Thereby, you can even do hologram that is practically invisible to anybody. And so in this way, you can secure your properties, your any form of material that you feel that if it is stolen can be a problem. So you can, as an anti-theft, you can describe it, and when this material is found, if it is scanned, you see your pattern and you confirm that this is the material that was stolen. Apart from that, it's used in DNA study, where you can see the DNA structure with the head of the AFM that is attached to it. Because essentially there is an AFM head, because what you are writing is just like when you are writing on the paper. You need to pick your pen and write on the paper, and you are seeing what you are writing. If you make mistake, what do? You correct it. The same thing here. So there is an AFM, atomic force microscopy, integrated onto this that helps you to view your writing and then see if there is any problem. You can easily do the correction on the system.
Next, we move to yet another laboratory where engineer Karim talks to us about Manflow's 1000C equipment.
The system is designed to carry out biochemical assay under shear flow. Traditionally before, most of these biochemical assays are carried out under static in vitro system. When you talk about static in vitro system, we have the use of test tube and the racks. The samples are loaded there, and there is no simulated flow as we have in living system, just like we have in my body and your body. So therefore, with the coming of this system, because of this system, biochemical assays are now given physiological importance and more relevance. Okay, the stage here we have the stage utilizes a plate. The plate consists of 48 wells. 48 wells. These 48 wells with 48 wells with 24 channels, meaning that 24 parallel experiments can be performed in parallel, thereby saving time. Okay, the plates are designed in such a way that the well, the input and the output well are so minute that the reagent needed to carry out any assay is of low volume, thereby being economical compared to the usual the orthodox method of using test tube and boiling tube. So we use the volume needed is less than 1 milliliter. Okay, the system is controlled by the whole system is controlled by a software that's embedded in this computer system. That's the montage of software. The system, within the system, 3 packages are loaded. One, a package to control the whole system in an automatic way, and a package for image analysis, and another package for data acquisition. Okay, so this using the Manflow's assay, the Manflow's system has a lot of applications. It can be used by microbiologists, the biochemists, in immunology. It can also be used in oncology, can be used in hematology. So talking about microbiology, you can use the system to study antimicrobial versus microbial relationship. With this, you can ascertain the effectiveness of any antibiotics. You can study how effective it is against a certain pathogen. Secondly, also in hematology, you can use it with the system. You can study platelet aggregation, platelet adhesion and aggregation. With this, we know platelet adhesion and aggregation is the major process involved in blood clotting, and blood clotting we know is the major when blood clotting we know is a major cause of when it happens when it is not unwarranted. It is a major cause of many of these heart diseases, like we have in hypertension and other cardiovascular diseases. Okay, also talking about oncology, you can use the system to monitor the molecular and cellular mechanism of cancer cell development and progression, as well as testing the effect of treatment on such processes. In an area of immunology, we can use this to study the pathogen versus the host relationship. So what you need to do in such a case is to just get some of the pathogens, the cell and the host cell, and you can now, with your test drug, so just put what you need to do is to get the cell, the microbes, that is the pathogen, get the cell of the host, and introduce them simultaneously into the well and study how they interacted. This could lead to, with this, we can easily understand how, with this interaction, we can come up with different methods of treating such pathogen.
Ademi Olumide explains iron sporting equipment.
Basically, what this machine does, it's very, very important in the researches into electronic devices and thin film technology. This is a thin film deposition equipment, and it's very, very important. You see, all these big and gigantic equipment the research started using thin film, how to miniaturize our big equipment like the cathode ray tube television we know in those days. Now we have plasma LED television. Research is started using this kind of equipment to deposit thin film. I would it is used as a preparatory equipment for CERN to deposit a conducting contact so that you can have a clearer picture in your CERN. Basically, that is what this equipment does. I will show us a plain glass slide that is not deposited without deposition. This is a plain glass slide. But after this equipment is used, you have something like this. Gold material has been coated on this glass slide, so you can see the difference between the two, the coated and the uncoated slide. Basically, that is what this machine does. And to operate, it's very, very simple. There is an argon gas attached to it, which creates a plasma, a form of plasma on the target. It just comes directly down on the substrate that has been introduced. This material can use different targets. We have gold targets that can be used with it. We have silver target that can be used with it. Any metal target can be used as a target to deposit this equipment. This here is a gold target that has been deposited here. This is a gold target. So you can use any target, silver target, aluminium target, copper target, whatever target that you have can be used on this equipment. Like I said, you can find application in researches in electronic devices, thin film technology for application in solar cell and semiconductor devices. In the same vein, I would also like us to introduce to this beautiful machine that you have here. This is called DC RF magnetic sputtering. This is a higher version compared to this one. That other one I showed you previously can only do one work, which is just to deposit. But a lot of things can be done, a lot of research can be done using this equipment. You can have reactive deposition, whereby you have different targets, whereby you have more than one target. You can have a copper target in one and a silver target in another one. Then you mix them together in different proportion to have a different kind of deposition at the end of the day, which can be taken for further analysis for characterization. This here is the control unit of this equipment. The whole control, the control of all these units can be found here. We have how to open the shutter, close the shutter, deposit, the time of deposition, and everything can be found using this kind of control system. Also, there is a chiller attached to this system because it operates in a very high temperature. It needs an equipment, it needs a coolant, something that serves as a cooling system, so that once the machine is in operation, it cools down. That is why you have a chiller attached to it. Also, you can have a reactive, a kind of gas reactive deposition for it, whereby you can introduce gas inside this chamber while the deposition is on. You can vary the time of deposition. You can vary the kind of the gas that is being introduced to have a beautiful deposition for research purpose. Just like I said, after the deposition here, it can be taken for further analysis. It can be taken for further analysis to characterize, so that you have a beautiful and based on the kind of deposition you want. And also there is another third deposition machine that I would like to introduce us to. It is also a deposition unit. This is a laser ablation deposition unit, which is quite different from that one that uses a DC and RF. Here, the beautiful thing about this machine is that it uses a laser. You know what a laser is? It uses a laser for its own means of deposition. This is the laser here, while the machine, the deposition vacuum system is here. Once the laser is on, it focuses on the target. This is the laser here, and this is the control unit of the laser. Once the laser is on, it focuses on the target, thereby emitting electron from the set target that has been there, be it aluminum target, gold target, any metal whatsoever can be used as a target for this equipment. Also, this equipment would find application in solar cells, researches into solar cells and semiconductor devices. It can also be used to form contact for our devices, for our electronic devices. A lot of work still needs to be done so that we can harness the beauty of this laser ablation. And also, with the laser ablation, you can be rest assured that you have a uniform deposition. You can have a uniform deposition, then you can also vary the time of deposition. The longer the deposition, the more the thickness you have for the equipment. Just like I said, this equipment will find application in electronic devices and researches into solar cells.
Thermal analysis is essential in material evaluation. Here we join Dr. Mrs. Ngozi Okorie as she explains the DSC instrument and laboratories under her purview.
This is an instrument that does thermal analysis. The TGA, which is the thermal gravimetric analyzer, studies weight change as temperature is increasing, and the DSC, which is the differential scanning calorimeter, studies the heat flow as temperature increases. It's an instrument that helps you to understand the behaviors of materials when they are under high temperature. It uses an environment that could be inert, you use your nitrogen gas, or an oxidizing environment where you have your gas flowing in it. With that, you can understand the basic thermal properties of a material. You can find the enthalpy, the heat loss as temperature is increasing. You can be able to get the phase change in various materials. It's actually very essential because basically if you look at all the instruments you've been introduced to, there's a need for us to understand the material that we're working in, so that you don't waste material. Assuming in processes like biochemical process where you have decomposition, because as most materials heat up, they get decomposed. Let's assume you're doing an energy or you want to produce biofuel. As your materials are decomposing, various elements are being given, various chemicals are giving out, and as they are giving out at various temperature, you're able to note what is present, and then you understand how the material would function when it's now in a real situation.
The truth is that the NASENI Center for Excellence in Nanotechnology and Advanced Materials has what it takes to make adequate contributions to national development. With skillful personnel and requisite equipment, the institute can provide services in areas of health, agriculture, manufacturing, and education. Avail yourself of the opportunity of enjoying the services of this complex scientific enclave located in Akure, Ondo State. Let me now introduce the center manager, Mr. Obiozo Chidozie Vitalis.
This center, that is called Center of Excellence in Nanotechnology. First of all, you can understand that the Center of Excellence can be regarded as an organizational environment that strives to generate new knowledge, either be it from talent or individuals, to apply it and get new products. We have a high quality product equipment that is here. Maybe you can find some of them either here in Nigeria, one place. So we're going to provide workspace for select distinguished researchers within and outside the country to come and use our facilities here to execute their project. That's the people that have knowledge but they don't have equipment. We're going to bring them here free of charge, but they'll bring their knowledge. We put it here because the equipment, you cannot afford it. Some of the equipment are very expensive. Even the accessories are very, very expensive that no individual can afford that. So we're going to provide workspace for such people. We are going to select them. You must bring their proposal, and then we'll look at it. And then we're going to sponsor some projects with people that have knowledge too, so that we can now publish it and then use the result to better our country and factories.
And it's here that we conclude today's edition of NASENI Milestones. The program returns next week. Thank you for watching, and goodbye for now.